All right, so let's deconstruct cloud pen testing. Let's take a look. All right, so I think we're all well aware, right? Clouds are growing. Clouds are a growing target. And an interesting number is that 82% of all breaches involve data stored in the cloud. So that could be an attack that starts in the cloud or an attack that starts elsewhere and then just moves into the cloud and also compromises cloud data. Interestingly, and that is something that I actually wasn't aware of before I started looking at this presentation, is that the cost of breach in the cloud is actually higher than on-prem. One of the challenges, and I'll have some more, and maybe a small joke here, I obviously didn't swim here, so there's going to be a lot of airplane language. I do come from Germany, so I did take some long flights to get here. One of the points when you look at the cloud is that, of course, you could also say there's no cloud, there's only someone else's computer. So it's very hard to maintain that visibility, right? To maintain that control that you feel you have when the data is on-prem. I'm not saying it should be on-prem, cloud's fine, but I'm saying it brings new challenges with it. That's kind of the aspect that I see here. And one of the points also is that usually there is no true cloud only, right? Even someone who has most of their data in the cloud would still have certain user systems on-prem, but I would say most customers that I see are truly in a hybrid situation. So all in all, there's always a connection, these two environments. Your office environment, your server environment, and then your cloud environment are interconnected. And like an airplane, right? They can maneuver in the air, in the clouds. They can also maneuver on the ground, right? So that's kind of the analogy here, where the airplane fits really well. Let's continue that down that path. The next challenge I wanted to put in your heads is that it's obviously difficult to understand the impact of things that might happen or affect the cloud, right? You'll have a ton of findings. Which one from the, let's say, 90,000 findings, could be vulnerabilities, could be configuration issues, whatever, which one of those is actually going to make it too easy for the attacker, right? To identify this one little bolt on your airplane, that's gonna be the difference between getting breached and staying safe, right? So you need to make sure that you're constantly aware of any changes and keep control. A classic risk in the cloud environment is definitely an over-permissive role. So if you have want to take the time to read through here, right? The S3 bucket exploration, look but don't touch. And then if we go to the EC2 instant field trip, responsible instance control, and you see the permissions granted, describe instance, start instance, stop instance, and all of a sudden, this is way more than look but don't touch. And you can see the access was approved. So that's not what we want to see. I'm saying the cloud itself is not new, but I think there is an extra level of complexity that is growing on us. Obviously, with cloud architecture itself, it's distributed, but if we put on-prem in the bucket, it's even bigger, right? It's everything. It's like asking what's your perimeter. It's everything. Your phone is your perimeter. Everything. It's fast changing, right? Nothing. I think few things are changing as fast as cloud, right? What's your number of workloads? What's your number of servers? That could change in seconds or minutes. And there's a very high level of automation. Obviously, that's what makes cloud interesting. We've heard speakers earlier today who said that many things have been done right in the cloud that we kind of failed to do on-prem, but it doesn't mean that everything is easy or kind of self-fulfillingly safe in the cloud. Unfortunately not. All right, let's take a quick look. We see the different aspects inside the account, right? This is an AWS example. That's the wider box. Then we have Azure and GCP on the side. So we see the workloads, we see the storage, database, identity, and all right. And we see our different cloud providers, which we see here the EC2 or virtual machines on the Azure side, the identities, the databases, or the storage, the Amazon S3 or blob storage on the Azure side. And now all of these resources are being spun up dynamically, automatically. We see there's constant change, right? And now we put Jenkins, Kubernetes, all of this in the game. And if you think of how, and we actually discussed this earlier today as well, how code is built, right? There's a fair bit of investment that goes into QA. So you always, whenever you create, let's say IT systems, code in this case, you always invest into double checking. And my point is you should do the same when you look at all your IT systems, which is you need to validate that the configuration and security are okay. All right, so let's take a quick look, right? With workloads, we have the misconfigurations, vulnerabilities, network hygiene, unpatched resources, unmanaged assets. So there's a bunch of stuff that can affect us here. Identities, we have the excessive permissions. We saw the slip before. Unauthorized access, that's even worse. Neglected accounts, right? This kind of shadow IT of users. And lack of authentication altogether. That would be really weird, but of course that does happen. When we look at the data, publicly available resources, exposed sensitive data, stored credentials. That's an interesting case. We're going to take a second look on one of the coming slides. Shadow and abandoned data as well, right? With the cloud, there's no physical indicator that something's actually here. You could actually miss something. You could forget about things. You lose your connection to things. There's quite interesting phenomena that can happen here. All right, so let's look at some use cases. I would say cloud penetration testing use case number one is the black box test. What do I mean by black box test? It means we do not test with credentials. We come anonymously, right? We come as any user from, let's say, the outside would look at us, at our environment. Very interesting use case. Second use case then is the gray box test. So we define a specific user and check if the access level that we expect to find to be configured is actually true, and if any pivoting, any movement from there is possible. Basically also checking if this user can find additional credentials, more passwords, let's say, or API keys inside that one environment that we're looking at to then move to the next one. Hybrid environment testing, I think this is very important, right? To look at a use case where an attacker would take control of your cloud environment and see if any progress or progression of this attack into your on-prem environment, into your office network would be possible. And of course, the other way around. Check if your users could get access to cloud environments that they should not be having access to. And last one, cloud configuration review, I think goes without saying. You need to check your config. That's a very important factor. Let's look at the methodologies, right? Cloud configuration review, we looked at this. Identity and resource, right? All the access. Cross resources, right? Can I get from this, this specific piece of data to a database, for example, right? Is it possible to extract a key and then get access to the data in the database? Cross account, can I, starting as one user, try to mimic a second user by getting access to their credentials, password, basically? And then also cross providers, right? So very often, and we're using AWS and Azure as examples here, but it could be anybody else, right? The point is you're most likely not using just one single cloud provider. If you are in the cloud, then you potentially have 2, 3, or more cloud providers. So that's quite an interesting use case for you. All right, so let's take a quick look at the native cloud testing. And now it gets a little bit more technical. We'll start at the top with the blue box discovered in AWS S3 bucket, right? This is a black box scenario. We don't know anything. I'm taking the perspective of the pen tester or attacker. We don't know anything about the AWS S3 bucket, so we're discovering it. And then we find that it has a public access policy. We then obviously access that bucket. We can list files and directories, and we find that there's a script that will potentially have credentials in it. And with that, right, we would have an identity accessing the resource. We would validate this credential to progress. We can discover AWS Lambda functions. And now with this, actually extract a plain text database connection parameter, which then further allows us to gather valuable information from host, and that means further credentials, which means we can access the RDS, the database instance, and we've extracted data from the database, right? So this vector, if this is possible, brings us quite a few learnings. It shows us where the attack got started, where the misconfigurations are, where we need to prioritize the fixing, which is at the root cause, right? But it also gives us the validation, gives us the risk, gives us the impact. The impact is an attacker can access data, right? So now there's no, no, this is not an important vulnerability that we found, but we actually have the proof that this attack vector is possible and can be used. So now we're looking at a compromised developer's account. I'll try to go a little bit faster. We validate an AWS credential, obtain the SSH key. We log into the SSH account, find that the user has privileged remote code execution capabilities. We do execute the API command. Right? From the secret manager, we move into the EC2 instance, enumerate the files, encrypt the files on the host, establish a connection with the malicious file. Right? Malicious, obviously this needs to be safe. Terminated backup services and delete logs and footprints. That is a Lockbit ransomware campaign for you right here, right? So this is how quickly such an exercise can then escalate and give you real findings showing how impactful this finding can actually be. And definitely needs to be prioritized accordingly, meaning we have completed the kill chain here. Last one, hybrid and meaning cloud and on-prem. We start with a credential that is exposed on a web page, like in an API key, for example. This is a classic example that we find often in customer environments. So this is being tested. We discover the corresponding Azure credentials. And again, we're moving cross-resource. With the 9.4, the red finding, we gather information and can find that we have a user now that has higher privileges, which now has access to a host, can execute code there, and would potentially be able to steal credentials from memory. And this way, we can pivot from a cloud attack vector into the core network, validating credentials of the domain admin here. Okay. This is just a quick overview of the workload, identity, and data details, mapping services, the type of configuration review and the misconfiguration that I want you to look out for. And with that checklist, right, that's exactly what they do in an airplane. Now that we've understood this, I thank you, and we are ready for takeoff.
When you're late because you assumed the taxi driver knows the way, then it's no surprise you'd assume the launderer would separate the white clothing from the colors. Or just assume there's enough toilet paper in the restroom.
What the hell?
When it comes to cybersecurity, don't assume. Validate.